Okay, so when we ran out of video, we were just finishing this question number 2 on the sheet, conservation of momentum and energy questions, and we were doing the G.I. Joe, and we were finding that the x component of v3's velocity was negative 41.797 meters per second. And again, negative just means opposite, and it should be going in the negative x direction. This should be v3fx. Okay, and so now we're going to do the y. So in the y we have our conservation of momentum equation, and initially it's not moving in the y. And so again, before you rearrange, put in your positives and negatives. So if you look, m1 is going up and m2 is going down. So m1 is going to go in as a positive, m1 v1 final, and the y is the opposite side, so sine theta 1. And 2 is going down, so minus m2 v2 final, and it's the adjacent side, cos theta 2. And then 3 will work out. Okay, so rearranging, v3f will equal, m2 term becomes positive because you've taken it over, m1 term becomes negative because you've taken it over, and then divide by m3. So v3f will equal m2, forget my numbers now, 14 grams, and it was 18 meters per second, cos of, was it 21? Yeah, cos of 21 minus 16 grams, and it was 25 meters per second, sine of 35 divided by 10 grams. v3fy will equal positive 0.583 meters per second. Okay, so what does it look like then? To find the sheet so I can move it. So we have a really big dude in the x direction going negative 41.797 meters per second, and an itsy bitsy little one 0.583 meters per second, oops, going up, not down. It worked out to be positive, going up. So of course I put my number in the wrong spot, so this will be v3f. So square them, add them together, find the square root. Take this out of here because it's bothering me. Okay, so it's really down here, 41.797, and this will be your v3f here. So square them, and you get v3f to equal 41.801 meters per second, and the angle is 0.799 degrees, and it's upward, which is clockwise, from the negative x. And you're done with G.I. Joe. Okay? Hopefully that makes sense. If not, ask questions. All right, number 3 on your sheet. Number 3 says a hard rubber ball is moving north with a velocity, so it's moving north with a velocity of 4.2 meters per second. So v1 initial, 4.2 meters per second. And its mass is 52 grams. When it collides with the stationary billiard ball, mass 155 grams. So m2, 155 grams, v2 initial, 0. Okay, if the rubber ball moves off with a velocity of 2.2 meters per second, an angle of 30 degrees clockwise from its original direction. So the rubber ball's going this way, 30 degrees, it said, clockwise from its original direction. Was the collision elastic? So v1f is 2.2 meters per second. So number 2 is going to go this way, v2f. And wants to know, is it elastic? But before we can find that, we have to find V2F. So you find V2F always, always, always using momentum. So in the x direction, m1v1 initial x, m2 v2 initial x equals m1 v1 final x plus m2 v2 final x. Okay, so this time, look, neither of them are moving in the x direction. Bring the first term over, m1 v1 final, and the x component is up here. It's going to be sine. Sine theta 1 will equal m2 v2x. So v2x will be negative. m1 was 52 grams. Final 2.2 meters per second. Sine of 30 divided by 155 grams. V2Fx will be negative 0.369. 0.369 meters per second in the x direction. Y. M1v1 initial y plus m2v2 initial y equals m1v1 final y plus m2v2 final y. It's not moving in the y, it's the number 2. Number 1 is only moving in the y. Bring this one over, minus m1v1 final. The y component is cosine. And that'll equal m2 v2 final y divided by m2. So v2 final y will equal m1, 52 grams, times 4.2 meters per second, minus 52 grams, times 2.2 meters per second, cos of 30, divided by 155 grams. V2 final y equals 0.769. If only I could see the next digit. Just one sec. I think it's a 1. 7691 meters per second. Okay, so there we have it. So we have going up 0.7691 meters per second, going to the left 0.369 meters per second. Square them, add them together, and get your V2 final. And when you do that, you get 0.8537 meters per second. Now, if you wanted, you could find the angle. And certainly if I asked you what at part A, what's the momentum of this ball, or what's the velocity of this ball, you would have to find the angle. But here I'm just asking you, is it elastic? So we don't really need the angle. We just go to 1/2 mv initial squared plus 1/2 m2v2 initial squared equal to 1/2 m1v1 final squared plus 1/2 m2v2 final squared. There's 1 in there. This guy goes to 0. And now I have to change to kilograms here. I didn't up here because they were canceling, but now I'm doing energy, so I have to. So what was it? It was 52 grams, so 0.52 kilograms. And it was 4.2 meters per second squared is equal to 1/2 0.052 kilograms times 2.2 meters per second squared plus 0.155 kilograms, and then times this 0.8537 meters per second squared. Okay, so when you do this on this side, you get 0.45864 joules. And first term on the other side, 12584 joules. And second term, 0.05648 joules. So 0.45864 joules initially, And when you add those up, 0.18232. I don't think they're